what we need to do to eliminate eliminate y from the first equation is, well, some of it's easy, but we've got to get rid of dy by dx. And dy by dx equals dz squared by dx, which is equal to 2z dz by dx. Adding that, substituting that in, then we get dz by dx. dy by dx is 2z dz by dx minus 4y, which is 4z squared, tan x equals 1. No, sorry, not equal 1, I'm looking at where we're going here, equals 2z. And now we can sort of cancel 2z's everywhere to get rid of that, and change that into 2z, which is exactly what we're after. So I'd write that out a bit neater. Now we need to solve this differential equation. It's a first order differential equation, so we're going to find an integrating factor. It's in the right form, so we want the integrating factor being e to the integral of minus 2 tan x dx. Now minus tan is actually good because it's minus sine of a cosine, which is minus logarithm of cosine, so we end up with that being e to the 2 log cosine x. Like that, which is good, again, because that's the e and the logs cancel to leave cosine x, and the squared is still there, so it's cosine x squared. So multiplying through equation 2 by this, we end up with cosine squared x dz by dx minus 2 tan x times cosine squared. Well, tan is sine of a cosine times cosine squared is sine times cosine, I think, equals cosine squared x. Something like that. Now, the point is that when you differentiate, now what we should see is that when you differentiate cosine squared, we get 2 sine x cos x. When you differentiate z, you get dz by dx. So this is simply the differential of cosine squared x times z. You didn't actually need to go through all that rigmarole, you could just write that down. Now I'll integrate to get rid of the differential bit. So that equals the integral of cosine squared x. And just making a bit of space here, changing the colour back to blue, we get cosine squared x times z. I'll write it that way around, it looks a bit better, equals, now we need to integrate cosine squared, so we write it in the usual way as half cosine 2x plus 1, like that. And so we end up with z cosine squared x equals 1/4 sine 2x plus half x plus c, and chucking everything together we get z equals half tan x plus half sec squared x plus c sec squared x. That's times x plus c sec squared x when we divide through by sec squared. Divide through by cosine squared. Got what part C said. Hence obtain the general solution to the differential equation 1. Well, we're told some numbers to chuck in, I think, at some point, are we? No, that is the general solution, what we're talking about. So all we need to do here is replace z with, I think it was the square root of y. So y, if z equals that, then y equals that squared.